Hi students, how are you? I hope that you are all preparing well for your JEE Mains 2023 examinations. Today I came before you to explain a very important topic in the chapter differentiation. Okay, so in the previous class, that is in yesterday's class, I explained about turning points and critical points, stationary points, those I explained. Now today I am going to explain the maxima and the minima of a function. So function is nothing but it is a curve. In the curve, given a domain, the function will take a maximum value and sometimes it takes a minimum value. At what point it takes maximum value, at what point it is take minimum value, what is a maximum, what is minimum, all those things I am try to explain you in detailed way. Okay, so let us don't skip this video. Until the end you watch this video, you will get a complete knowledge. Okay, so let us start our syllabus. See here, there is a curve here. There is a curve of function y is equal to f of x. Y is equal to f of x. There is a function. The curve is like this. If you observe at the points A, B, C, if you draw the tangent, they are parallel to x-axis. That means they are called A, B, C are called stationary points. Stationary points. Yesterday I explained what is stationary points. So these are the points in which, for example, if it is x is equal to A, f dash of A is equal to 0. F dash of A means what? If you draw at x is equal to A, if you draw a tangent, the tangent will be parallel to x-axis. Okay, so that's why these are all called stationary points and sometimes they are also called turning points. They are called turning points also. Why? Because the curve takes a turn. That means here, if you see here, so increases from this point, the function is decreases. That's why these points are called stationary points or sometimes they are called turning points are also. Here also, this point at the point x is equal to c, f dash of c is equal to 0. That means the tangent at here, the curve f dash of c is equal to 0 means what? If you draw a tangent at c, the tangent is parallel to x-axis. Since the slope of x-axis is 0, therefore f dash of c is equal to 0. Then that point is called stationary point. Understand this? That means that curve takes a turn. That means it decreases from c, the curve starts increases. So these are all called stationary points. These are also turning points. Now you may ask one doubt. Sir, at B, is it called a stationary point? Yes, it is called a stationary point. Even though it does not turns, it does not take a turn. If you observe from left to right, the curve go on decreasing and take some flatness is there. Again it start decreasing. Understand? So this is also called stationary point also. But there is a special name for that. That B is called point of, this B is called point of inflection. At the point of inflection. Understand? Here the point B is called point of inflection. Okay, means that means the curve takes a turn. Here the derivative is 0, but it is not a turning point. It is not a turning point. Turning point means what? From maximum to, from increasing to decreasing, from decreasing to increasing. So this is not a, we cannot call it as a, here B cannot be a turning point. B cannot be a turning point, but the derivative is 0. Derivative is 0. So point of inflection is, so B is the derivative exists. derivative is equal to 0. The derivative is 0 here. Derivative of if you find out at x is equal to b, at x is equal to b, f dash of b is equal to 0, but it is not turning point. But it is not turning point. Understand this? So here B is not A and C only turning points, but B is not a turning point, but it is not a turning point, but the derivative is equal to 0. Here if you see that, if you draw a tangent, that will be parallel to x. So best example is point of inflection is, for example, if a person is crossing like this in the U shape. That means he started from here and you are moving and this and so here somewhere where from here again he start taking the direction. He changed the direction. So he walked from left hand side, again he came from here right hand side. This point is called point of inflection. Point of inflection means what? It is not the derivative is equal to 0, but it is not but the derivative is equal to 0, but it is not a turning point. Okay, now, right. So this is called stationary points. These two are stationary points, but here derivative of that function is 0, but that is not a turning point. Now we are going to see, given a function where it have what is meant by local maxima and what is meant by local minima. So let us see that concept. Welcome to this concept, that is what is local maxima and local minima. Afterwards I will explain what is global maxima, global minima. So what is the difference between local maxima and global maxima, local minima and global minima. So generally students will get confusion there. Okay now. So first let us learn what is local maxima and local minima. Okay now. So let us take a two-dimensional system that is equal to, this is a x-axis and it is a y-axis curve. There is a function y is equal to f of x. Let us say that its curve is like this. So like this, its a curve is like this. Y is equal to f of x curve. So y is equal to f of x. See here, anybody even without any mathematical knowledge also, we can say that it is called local maxima. Here local minima. Here local maxima. Here local minima. Here local maxima. Here local minima. What is meant by local? So it's such a one curve. Does it will have these many types of local maxima, local minima? Yes, it will have. What is meant by local maxima means, for example, a curve is said to have local maxima at x is equal to a. Local maxima at x is equal to a. That means if it is a, f of a value is greater than any other value in the neighborhood of a. In the neighborhood of a. That means a point x is equal to a. That means here it is said to be a local maximum. That means this f of a value. So this value is there, no? That means f of a means this is f of a should be greater than any other value in the neighborhood of a. That means neighborhood means what? Up to here you see here neighborhood. This is called neighborhood of a. This is the neighborhood of a. That means this is a plus h, from this is a minus h, where h approaches to positive. Okay, na positive quantity. In the neighborhood of, that means in this neighborhood, f of a should be greater than 0. In the neighborhood of, that means in this here, if you observe here, it should be greater than 0. That is called local maximum. Up to that it is a local maximum. That means there the curve takes a turn from maximum to minimum, maximum to minimum. This is called local maximum. What about local minimum? So for example, x is equal to b. We call it as x is equal to b local minimum, x is equal to b. That means f of b is called local minimum. F of b is less than, what is the f of b value is less than any other value in the neighborhood of b. That means what? What is the neighborhood of e? See here b plus delta, here b minus delta. Here h, there I delta I have taken. So if you see the neighborhood of b, so this is the neighborhood. That means f of b value should be less than any other value, should be f of b value should be less than any other value in the neighborhood of b, that functional values. That is called local minimum. Understands? That means in the neighborhood of a, f of a will be the greatest. Remaining all values should be less than f of a. Then f of a is called local maximum in the neighborhood of a. Neighborhood means side from a, some left side values and right side value. Here local minimum means the f of b value should be less than 0 for all values which lies between in the neighborhood of b. Understand this? So all this, if you draw these lines here, so this is f of b, all values. So f of b will be the least one. So if you f of a, this is remaining all values you write down. So this is what are the functional values. F of a will be the maximum. Here f of b will be the minimum. So this is called local minimum and it is called local maximum. So given a function, whatever may be the curve, so it will have any number of local maximum or local minimum. Okay now. So if you observe here, sometimes here local minimum, local maximum and local minimum. Sometimes see here, one very, very important point. There is a function like this. Like this. If it is a function is like this. Observe here local. So this is a local minimum. Here local maximum. Local minimum is greater than local maximum here. Understand? Here local minimum is greater than local maximum. Local minimum is greater than local. Sometimes it may be possible. Sometimes it may be possible. Okay now. So this is a local maximum. Okay, local maximum. So this is a local minimum. Okay. So if you take one more curve like this, here local maximum. So again local minimum is greater than local maximum. Sometimes local maximum will be less than local minimum. So that is we cannot say this is the final. Local means what? In the neighborhood of that point, x is equal to a, that is the top. In the neighborhood of x is equal to b, that is the least. Understand this local maxima and local minima. Okay, right. Given a function, how to check? With it is a definition point of view we explained, but given a function, how to check whether given point is a local maximum or local minimum mathematically or using differentiation, how to check? Let us see that concept also. Welcome to the concept here. Mathematically, how to say whether given at a point it is a local maximum and at a point the point is local minimum. Let us see that. So very, very easy concept. This is so x-axis and this is a y-axis. Let us say a curve like this. So at x is equal to a, so it is a very clearly the local maximum is exist. But how to say that by our naked eye? If we see that, we say that it is a local maximum. Local maxima is there at x is equal to a. But mathematically, how to say that? For that, take a in the neighborhood of a, let us take any 2 points, that is this is a plus h, here it is a plus delta and it is a minus delta, where delta is a approaches to positive real number, positive 0. That means that delta is a very a small value. That means delta is approaches to 0 plus means what? It is a 0, it is approaching 0 plus means what? So, it's a delta is a very small value. That means these 2 points are just side by this, side by x is equal to a. So, to make you understand, so I am writing a little bit distance. Okay. So, this is equal to f of a. Okay now. So, if you observe here, so this is f of a plus delta. So, this is what? F of a minus delta. Observe here the point f of x is equal to a called local maxima if and only if f of a minus delta is less than f of a is less than a plus delta, f of a plus delta. Understand this? That means for all points in the neighborhood of x is equal to a, neighborhood of x is equal to a. That means in the neighborhood of x is equal to a, we take any point, you take any point, the condition should be f of a minus d should be less than f of a, f of a minus should be less than f of a, and f of a should be greater than f of a plus d. F of a minus d should be greater than f of a, and f of a, I can separately write it, and f of a should be greater than f of a plus d. Understand? A minus d should be less than f of a, and f of a should be greater than f of a plus d. Then the point x is equal to a is called local maximum of the function in the interval in the neighborhood of x is equal to a. Okay. Now, what is local minimum? Let us see that local minimum value. So, this is equal to x axis and it is a y axis. Let us take a curve like this. Okay now. So, here if you see here x is equal to a. By naked eye, by seeing this x is equal to x is equal to a, if the x is equal to a is the local minimum and the local minimum value is f of a. Anybody can say that. But mathematically how to see that? In the neighborhood of a, let us take, otherwise I will take b here, no problem. Here I have taken a, let us take b here. Let us take 2 more points in the neighborhood of b. That means b plus epsilon, b minus epsilon. Epsilon approaches to 0 plus. That means so it is approaching to 0. It was approaching to 0, positive 0 means what? So, delta, the epsilon value is a very small value. Okay now. So, observe here, this is equal to. Okay now. So, what is this value? So, this value is f of b, that means this value f of b, and its value is f of b minus epsilon, and its value is f of b plus epsilon. Okay now, whatever may be this value, f of b minus epsilon should be less than f of b, should be less than f of b. Again, f of b value should be less than f of b plus epsilon. That is f of b value, f of b minus e, here also should be greater than here. Again, it should be greater than f of b, and f of b should be less than f of b plus epsilon. F of b minus epsilon should be greater than f of b, and f of b should be less than f of b plus epsilon for all points. Then b is called, that is a local minima if these two conditions satisfied, and f of b is called the local minimum value. Understand this concept. So, these concepts will be useful for solving certain number of problems. So, here have you observed, did any derivative concepts here? So, our main chapter is differentiation, limits, continuity, differentiation. Am I used any first derivative, second derivative, dy by dx, f dash of x, anything I used? No. These are all general definitions we are using. But there are problems for which, so checking these inequalities will be sometimes difficult. So how to say given a point, it is a local maximum and local minimum? How to say using the derivative concept? Okay, na? Right. But one thing we can say, using derivative at whatever maybe it is a local maxima or local minima. Whatever may be that at local maxima and local minima, f dash of a is equal to 0, f dash of b is equal to 0. That is perfect. Why? Because they are all the turning points. All local maxima points, local minima points, they are turning points. So here maximum, again it will comes to minimum. So here decreasing, again increasing. Sure, they are turning points. At that points, we know that f dash of a is equal to 0, f dash of b is equal to 0. That means if you draw the tangents at those points, definitely those tangents will be parallel to x-axis. Here also if you draw a tangent, the tangent will be parallel to x-axis. That's why slope is equal to 0. First derivative is equal to 0. But how to decide that that point is a local maximum and how that point is a local minimum? Understand that? For that, we will make use of the second derivative. For first derivative, we can declare that, for if you use the first derivative, we can declare that at that points, we will get local maximum or local minimum. Pakka. But in this, if you want to differentiate clearly which is maximum and which is minimum, we have to take the help of second derivative of that function at the point x is equal to a. Okay, now then how to take the second derivative? Let me explain clearly. Welcome back to this concept, that is second derivative test to decide the point of maxima and the point of minima, at which point the function gets maximum, local maximum, and at which point the function gets local minimum. Okay. So very important concept. Okay, so let us see this concept. Okay, so let us take this is a x-axis and it is a y-axis and origin 0. Okay, so there is a function like this in a certain interval, it is getting like this. Okay, now right at x is equal to a set, so it has a local maxima, it has. Okay, now let us take in the some neighborhood, this is a minus delta, this is a plus delta, in the neighborhood of a minus delta and a plus delta, observe here. Okay, now right. At x is equal to a, we know that f dash of a is equal to 0. Why? Because if you draw a tangent at x is equal to a, the tangent will be parallel to x-axis. Therefore, the slope of the curve, the slope of the tangent at that point f dash of x is equal to a will become 0. That's everybody know. That's why that is called turning point, and the turning point we call it as a local. The at x is equal to a, we will get local maximum. Okay, now right. If you observe in the interval a minus delta to a, that means up to here you observe, up to here. If you draw the tangent, wherever may be the point here, there are infinite number of points are there. Whatever may be the points, if you draw the tangent, that means it is making acute angle with the x-axis. Acute angle with the x-axis. That means the slope of this tangent is positive. Why? Because acute angle means it lies in first quadrant. So tan theta is positive here. Tan theta is positive. Therefore, all these tangents will have positive slope. Understand? All these will have positive. Why? Because if you draw the tangents, all the tangents will make acute angles with x-axis. Understand? So the slope of these curves will be positive. If you observe, that means slope of the tangents are positive. Now, let us observe the interval from A to A plus delta. A to A plus delta. See here, delta is a very, very small value. Understand this. Observe here from A to A plus delta, how many points will be there? There are infinite number of points will be there. That is a decreasing there. Decreasing function. If you draw a tangent here, definitely the tangent makes obtuse angle with the x-axis. Obtuse angle with x-axis. Right or wrong? Yes. Whatever may be the tangent, like this tangents will come. Infinite number of tangents will come. All are makes obtuse angle. Obtuse angle means what? 90 to 180. That means 90 to 180 means lies in the second quadrant. That is equal to Q2. Second quadrant means the tan theta will be negative. So, the slopes are negative. All the tangent slopes are negative. That means as you move from A minus delta to A plus delta, A minus delta to A plus delta, that means from left hand side to right hand side, what will be the slopes of these tangents? At exactly x is equal to 0, that means they are positive to negative. They are coming from positive to negative. Positive to negative, from positive to we are getting negative means you are decreasing or increasing. That means decreasing. That means what decreasing? What is decreasing? Dy by dx values are decreasing. Dy by dx means what? Slopes of the tangents. Dy by dx is nothing but slopes of the tangents are decreasing from positive to negative. Decreasing. That means the derivative of these, is decreasing, less than 0. That's why d square y by dx square is less than 0 at x is equal to a. At x is equal to a. Understand this? At x is equal to a, if you observe the derivative of the function, second derivative of the function d square y by dx square is less than 0, then we say that the function will have a maximum, local maximum at x is equal to a. First f of a is equal to 0, then d square y by dx square at x is equal to a. If you say at x is equal to a, clearly speaking, d square y by dx square. If at x is equal to a, if it is less than 0, why? Because from positive to negative we are going. That means the derivative values are increasing, the slope values are increasing. That means it is an increasing function. If all the slopes, if you take it as a, consider that as a curve, that is a decreasing curve. Positive to negative, that is a decreasing curve. For decreasing, f dash of x is less than 0. For decreasing curve, f dash of x is less than 0. That means the d by dx of dy by dx is less than 0. Therefore, the second derivative is less than 0. Understand? So, for a local maxima or local maxima or simply maxima, first you have to find out f dash of a is equal to 0. Okay, afterwards, if it is d square y by f double dash of x, if double dash of a, f double dash of a will be less than 0, then a is called the local maximum. Here you will get that value is the local minimum. Let us see what happens for a local minimum value for second derivative test. Okay, now welcome back to our concept. So we are checking minimum value. How to check the minimum value? Okay, now. So let us take this is a x-axis and a y-axis. There is a curve. So here at x is equal to b. It has a local minimum value. Anybody can say. Let us take the neighborhood of b. Neighborhood of b means, let us take here x is equal to b plus epsilon. Epsilon means a very, very small quantity. Here he is saying epsilon tends to 0 plus. That means epsilon value approaches to 0. Right. So here left hand side you will have x is equal to b minus epsilon. Understand? B minus epsilon. At exactly x is equal to b, at exactly x is equal to b, we have f dash of b is equal to 0. Why? Because it is a turning point. It is a turning point. So if you draw a tangent at x is equal to b, the tangent will be parallel to x-axis. Therefore, the slope of that slope of the tangent at the point x is equal to b will become 0. Both are, say, why? Because slope of x-axis is equal to 0. Okay. Now, let us see what happens this side. That means in this interval, that means b minus epsilon to b. In this interval, how many points will be there? Infinite number of points will be there. Let us take any point. Let us take a point. Draw a tangent. Definitely that makes obtuse angle with respect to x-axis. Obtuse angle means what? Negative slope or positive slope. That is negative slope you will get. First negative slope you will get. Understand? So if you negative slope you will get dy by dx. If you draw any tangent, that means up to here only I am telling. Any tangent, it is making more than 90 degrees with the x-axis, negative slope. Right. If you take from b to b plus epsilon, that means in this interval, that means increasing. If you draw a tangent, let us take any point. If you draw a tangent here, it makes an angle theta with x-axis, that is acute angle. Acute angle means what? Theta lies in the first quadrant. In the first quadrant, tan theta is positive. Here, theta is obtuse. Obtuse means more than 90. More than 90 means it goes for second quadrant. Second quadrant, tan theta is negative. That's why slope is negative. Here, b to b plus a. Here, slope means what? M value will be positive. Okay, that means negative to positive. The tangent slopes of the tangents are from negative to positive. Negative to positive means what? Either increasing or decreasing. From negative values to positive values you are getting. So here negative value, 0. Again positive values it is rising. Negative value, 0. Again positive value it is rising. Understand? So negative to positive means what? The slopes are increasing. When they are increasing function, we know that wherever increasing function, we are already after f dash of x is 0. Slope means what? It is a function of y, dy by dx. It is the slope. It is increasing. What is increasing? Dy by dx is increasing. Slope of the tangents are increasing. That means the second derivative, d by dy by x, at x is equal to b should be increasing, greater than 0. Understand? That is d square y by dx square is greater than 0 at x is equal to b. Then b is called local minima. That means at x is equal to b, you will get local minimum value. Understand? If it is d square y by dx is less than 0, you will get at x is equal to a maximum value. At d square by dx square is greater than 0, you will get minimum value. Understand? This is called second derivative test. Understand here? Okay. I hope that now this is called local maxima, local minima. And one more concept is there, that is global maxima and global minima. Generally, students will get confused with these two words, local maxima, local minima, global maxima and global minima. So, no confusion. There is a slight difference is there between these two concepts. Okay. So, what is global maxima, global minima? That I will explain in the next class. Until then, all the best.